In the next chapter, we are going to have to use our factoring that we already are supposed to know. And so to refresh your memory, we're doing some review on that. And I believe the instructions say, remember what? Factor out a GCF. The reason you need to factor out a GCF is the numbers get really big if you don't. So in this problem number 1, do we have a GCF? Is 2 the GCF? No, 2 is a factor, but it's not the GCF. The greatest common factor is 4. And so what do you get when you factor out a 4? 4 will go into 25 times. 4 will go into 250 times. Now, this is the more difficult kind of factoring because this leading coefficient right here is not 1. So this is the longer kind of factoring, but you start out by multiplying the first number times the last number, and that would be negative 150. And so you need to write the factors down in the margin or somewhere. The factors of 150 are, of course, 1 in 150, and 2 in 75, and 3 and 50, and 4 doesn't go into it. And there may be some additional factors, but that's enough. And so, since this is negative, I need at least one of these to be negative, and I need them to add up to this number right here. Which pair could add up to a 5 if we put the signs in there? If I put the signs in there like this, these add up to get 5. Now, again, this is the longer kind of factoring. It is factor by grouping. And this 4 is just going to hang around out there in front. 3x squared minus 10x plus 15x minus 50. This 5x divided into 2 pieces. These 2 numbers, if you add them together, they're equal to the 5x. And why would I want to do that? Didn't that just make the whole thing more complicated? It did, but the reason you do that is so that you can make 2 groups of 2. So you can get a common factor out of this group. What's the common factor here? And what's the common factor here? Okay, and the 4 is just going to hang around in front. Don't lose it. Okay, and so the x is going to factor out, and when you take an x out of that, you have 3x left. When you take an x out of that, you have 10 left. When you take a 5 out of that, you have 3x. 5 out of that. Do you find any common factors? And so that factors out, the 4 is still in front, and the x plus 5 becomes the second factor. This term and this term make the second factor. We are only factoring, we are not solving. That's it. Do not lose that leading coefficient number there in front. It is part of the answer. Questions? Okay, problem number 3 is what we're going to do next. Problem number 3 does not have any common factors. So you start by multiplying the first term by the last term, and I already multiplied that out. And I wrote down some of the factors, maybe not all of the factors. By the way, how would you get these factors if you don't know what they are? You would take the 224 and divide it by 2. If you take the 224 and divide it by 3, it doesn't come out even, so that's why it's not here. And you divide the 224 by 4 to get the 56. Now, I am looking for a pair that is going to add up to give me the negative 52. Do we have a pair like that? If I put the signs in like that, would this add up to give you negative 52? So this would be 7a squared plus 4a minus 56a minus 32. This divided into two parts. So I can make two groups of 2. What factors out of this first pair? What 56 and 32? Do we know a common factor for those? And if this is negative, I need to factor out a negative. So I'm going to factor out an a out of the first pair. If I take an a out of that, I have 7a left. If I take an a out of that, I have 4 left. 56 divided by 8 is 7. 32 divided by 8 is 4. Negative divided by a negative makes a positive. Do we have a common factor? 7a plus 4. A minus 8 is your second factor. This makes your second factor. All we're doing is factoring. That's it. We're not going to solve it yet. Yes, some people learned this already. Some people are still working on learning it. The next one I want to look at is problem number 7, because some people had difficulty with the binomial problems. Why is this a binomial? It has 2 parts. And so the first thing we look for is a GCF. Is there a GCF? And so I factor out an n, and that's it. That's all. It's factored.